morning functions. All right, what I want you to do is do this warm up. These are two problems that came up a lot that when I was helping students on Friday that they needed help with. I'm sorry I'm not here again today. I will be back tomorrow, but we are going to start the next part. We're going to start working on our meeting level skills. We're not quite there. This will be the beginning of progressing, or the end of progressing, and we'll be going into meeting when I come back on Tuesday. So this is like the last part of progressing. Go ahead and do this warm up. Go ahead and hit pause. It should take you 5 minutes to complete this. So you got 5 minutes to complete this. Okay, so hopefully you took about 5 minutes to complete that. You've already hit pause. So here's what we're going to do. I've got 1, 2, 3, I have 4 terms that I'm going to need to simplify both top and bottom. Now I see that this is exactly the same, this is exactly the same, and then that's where it stops being exactly the same. So I can't just start. It would have to be every single one of these terms would have to be exactly the same as every single one of these terms for me just to cross it out. If you did this right here and you did this right here, you killed a cat. We've talked about this. We don't want to be killing kittens. You have to factor. We cannot do that. So what we're going to do is we are going to factor by group using grouping because there's 4 terms for both of these. So I'm going to make a box. These boxes aren't great. I'm going to do PR. I'm just going to do the numerator first. QR, PS, QS. All right, so I can factor out an R here, and I would need to multiply that by P. Then I would need to multiply, oops, that's supposed to be a Q. And then I need to multiply that by S, and S times Q does equal that. So the numerator factors to S plus R times P plus Q. Then I've got to do the denominator. So I erased what I just did, sorry. I had made a mistake, so I'm going to go back. Okay, so then I have to do the denominator. And I'm going to put PR, QR, negative PS, negative QS. All right, so then I can factor out an R there, and I need to multiply that by P and Q, and P times negative S will give me negative PS, and negative S times positive Q equals that. So then my bottom factors is R minus S times, let's see, P plus Q. And I just have to look for the things that are exactly the same on the top and the bottom. This is a big one. So my final answer would be R plus S, R minus S. I just wanted to line the R's up just to make sure that wasn't the opposite, the quotient of opposites, and it is not. So that would be my final answer. This one, we have to multiply by the reciprocal. So I'm going to go ahead and write K squared minus 4 over 3K squared, which doesn't change. And then I'm going to change the multiplication, and I have to flip it. So I'm going to have 11K here, and then I'm going to have K minus 2. Now I need to factor. This is a difference of squares, so we have K minus 2 times K plus 2 times 11K. That didn't change. And then I need to factor this 3K. So I have 3K, K times K minus 2. Okay, now I need to look for the things that are exactly the same on the top and the bottom. Well, this K minus 2 and this K minus 2 cancels out. And then I do have a K right here. This K and one of these K's cancel out. So I'm left with K plus 2 times 11 over 3K. And that should be your final answer. All right, so if you have any questions, let me know. Again, just a quick reminder, factor, factor, factor. You need to factor. All right, we are going to be adding and subtracting rational expressions. We are going to start with adding. We're going to add rational expressions with common denominators. So we're not going to move on beyond that. So go ahead and in your notes, I would just type, or sorry, not type, but write adding rational expressions, because I will pick up there on Tuesday when I come back. So adding and subtracting rational expressions have the same rules. When to add or subtract rational expressions, you have to have the same denominator. It doesn't matter. Adding and subtracting fractions, you always have to have that common denominator. You find the common denominator by finding the least common denominator. So you don't want to just multiply both of them. Sometimes that's the way it works, sometimes it doesn't. And then you want to add and subtract the rational expressions with different denominators. So that's what we will be doing. All right, to add or subtract, you must get common denominators. You can only add and subtract the numerators. Once you get a common denominator, the denominator won't change until it's simplified at the end. So once you find it, leave the denominator alone. All right, so we're going to add and subtract rational expressions with the same denominator. That's what we're going to start with today. So here are the steps for adding and subtracting rational expressions. So we are not going to be covering this part yet. We will go over that when I come back because this is the hard part. So if the denominators are the same, add or subtract the numerators, place that result over the common denominator, and then simplify. So those are the two steps that we're going to cover. So go ahead and hit pause and write those down. Again, I will be going over what to do when we have different common denominators, so you don't need to write that part. You don't need to write this part yet. So you could just skip this part. Okay, go ahead and hit pause one more time. I'm going to give you about a minute to write this down. Okay, so hopefully it's been about a minute. So to add and subtract, these already have common denominators. So we are going to rewrite this as 7x plus y all over the same common denominator of 9. This is something you probably have seen before. And then that is our final answer. There's no simplifying. I can't factor anything out. So we're done. Now we're going to do x over 3x cubed minus 14 over 3x cubed. So go ahead and take about 30 seconds to write that down. Okay, it's been about 30 seconds. So then we end up with x minus 14 over 3x cubed. Well, I can simplify 8 minus 14. So let's go ahead and do that. So then we end up with negative 6 over 3 over x cubed. Now this is just a simplifying problem. Negative 6 over 3 does simplify. So that's going to simplify to negative 2 over x cubed. Again, if you need it to see it visual, we could factor this. We would have negative 2 times 3 over 3x cubed. This would be our big 1, and that's how we're left with negative 2 over x cubed. All right, this one's a little bit more difficult, so I'd like you to take about 30 seconds and write this example in your notes. Again, the common denominator says that we can combine these. So we're going to get r plus t over r squared minus t squared. Now, r plus t does not factor any further. But r squared minus t squared, well, that's a difference between two perfect squares, so it does factor further. So we're going to end up with r plus t over r plus t times r minus t. Okay, now we have that common denominator. It's totally factored. Now we can find the same things that are on the top and the bottom, and the r plus t is the same on the top and the bottom. So then we end up with 1. So remember, it doesn't disappear. It doesn't cancel out. It turns into a big 1. Okay, that turns into a 1. We want to remember that. All right, and this one's even more complicated, so I would like you to try this one. So go ahead and hit pause. I'd like you to take about a minute to write this down, and then we'll go over it together. Okay, so what we can do, this is exactly the same as this one. That we have our common denominators. So we will get 6 plus x over x squared plus 3x minus 18. Well, that factors, right? That's just a trinomial factoring. So we're going to end up, if we factor that, so the factors of negative 18 that add up to 3 are 6 and negative 3. So we get x plus 6 over x minus 3. And then the 6 plus x, it does look a little different, but this is basically the same thing as this. So this is going to turn into a big 1. That turns into a 1. And we end up with 1 over x minus 3. Okay, So that is the last example I wanted to cover with you guys today. I would like you to finish part 1. I'd like you to walk into the classroom Tuesday morning, December 6th, ready with part 1 being completely finished. I do have a worksheet off over here up by my desk on the trapezoid table. I've got a worksheet for you if you finish everything. If you would like to, you can start part 2. It's available to you, but you might get to a part where it gets a little confusing. And if that happens, that's fine. Just go to the worksheet. Otherwise, I will see all of you on Tuesday. I hope you have a great day. Bye.